Hello and welcome. Today, we're excited to showcase the latest update to our web tool, Entrada. Right now, you're viewing the Entrada login page. Simply enter your username and password to gain access. Once you log in, you'll be greeted with a pop-up window. This feature is designed to keep you informed about our most recent updates and provide helpful tips for navigating and utilizing the tool effectively. You're now on the main page of Entrada. This interface is organized into 8 primary tabs, each serving a unique purpose: Input, Input Summary, Output, Speed Post Processing, Charts, Lookup, User Guides, and Update Histories. Let's dive into the Input tab. This is where your journey with Entrada begins. In this section, you are required to input all the essential information for your analysis. The Input tab is divided into 6 main sections, each designed to be intuitive and user-friendly, guiding you smoothly through the data entry process. Let's begin with the Batch in Input section. Here, you can upload your previous Entrada files. Once uploaded, Entrada will automatically populate the input fields with data from the batch file, streamlining your workflow. Next is the Entrada Input section. This part requires your attention to 6 fields. Analysis Scenario Type: choose the scenario for your analysis. Period: specify the time period for your project. Segment Length: mile, represents the length of project in miles. Essential for signalized facilities and specific travel time models. Is the analysis segment signalized? Indicate whether your segment has a signal. Does it remain signalized after project completion? Confirm if the signal stays post-project. Analysis Facility Name and Number provide the route name and number. Area Type: select the area type of the facility. Details available in the Lookup tab. Project Title, Project Number, UPC number. Enter the project name or a related number. Analysis Segment Beginning and Ending. Mark the start and end points of your project. Direction or ramp: indicate the direction of the analysis facility. Ramp analysis also selected from here. V.district. This file has 9 options. Jurisdiction: choose a jurisdiction that the district is in. Terrain: you may select among the following terrain types, which in combination with truck's passenger car equivalence rate is applied to the hourly traffic volume for the calculation of the VC ratio. Years for analysis: choose the years for your analysis. Years of existing, interim, and design. These drop-downs are your starting point, where you'll specify the relevant timeframes for your analysis. I encourage you to take a moment to carefully enter the necessary parameters. Moving to the second section, Scenario Details Inputs. This section's configuration depends on your selection in the section Entrada Input, which sets the foundation for the analysis. Analysis Facility Type. This field is pivotal. Here, you need to select the type of facility you're analyzing. Facility Cross-section: indicate whether your facility is divided or undivided. Posted Speed: enter the official speed limit for the segment. Its options determined by the selection of facility type. Free Flow Speed Calculation. These fields will automatically compute the free flow speed based on the data you've provided earlier, simplifying your workload. Number of lanes. The number of lanes is per direction. This allows for those facilities where the directional number of lanes is not uniform. The program is limited up to 10 lanes per direction. The free flow speed is adjusted on freeway facilities having less than 5 lanes per direction, in accordance with procedures in the HCM. Lane width. Here, you'll enter the width of the lanes, a key factor in determining capacity and flow conditions. Not all facilities have 12 feet lanes. Per HCM recommendation, the free flow speed is adjusted if the lane width is less than 12 feet. Shoulder width, choose a number from 0 to 6. The lateral inputs are for inner and outer shoulders. The free flow speed is adjusted based on HCM recommendation when the shoulder width is less than 6 feet. Access density, measured as the total number of unsignalized intersection or significant private entrances per mile of the project. Analysis segment number of traffic signals, the total number of signals that are located within. Average cycle length, enter the average duration of one complete signal cycle. Average green time per cycle. This is the average duration of the green light within each signal cycle. Signal coordination, also known as the delay adjustment factor. The delay is computed using following inputs. Each of these fields is designed to capture specific, vital information about your project, ensuring a comprehensive and accurate analysis. Please take the time to fill out these details meticulously. In the third section, titled Volume Delay Parameter Inputs, we delve into the specifics of modeling travel time based on volume and delay. Volume delay function is called BPR Bureau of Public Roads. ENTRADA provides BPR and non-BPR volume delay formulation for calculation of speed. The non-BPR selections are Axelic, Boston Cap, Conical, and Davidson models, which requires additional inputs. The ENTRADA applies an average formulation approach for BPR option, recommended by V.HCM and FHWA. Travel time estimation is determined by the selection of facility type and posited speed, and its result is average of multiple VDF estimates. It's important to understand that the selected travel time model can significantly impact your analysis results. Therefore, choose the model that best reflects the traffic conditions and characteristics of your project area. Refer to the lookup for detailed descriptions and guidance on each model's application and suitability. In the fourth section, Truck and AADT Inputs, your focus will be on inputting specific traffic data, particularly related to trucks and overall traffic volumes. Truck input type, ENTRADA converts trucks into passenger car equivalents for purposes of estimating volumes and VC ratios. The hourly truck selection requires classified truck data as the percentage of hourly traffic volume. The classified truck data are broken into 2-axle with 6-tire trucks, including buses, and 3-axle or more, such as single-unit trucks and tractor-trailers. The daily truck inputs are based on daily truck volume, which is divided by the daily total traffic volume. Users should select daily and hourly for scenarios where it is anticipated that the overall percentage of trucks or the hourly percentages will differ from existing conditions. It's important to select the truck time type that best represents the traffic conditions of your project. Daily percent of truck, this field requires the average daily percentage of truck traffic. Accurately inputting this percentage is crucial as it significantly influences the analysis, especially in areas with heavy truck traffic. Two-way AADT. AADT stands for Annual Average Daily Traffic. This field is where you input the total volume of traffic, accounting for both directions over a typical or average day. The volume should be rounded up to the nearest 100. Your input here forms the basis for many of the subsequent analyses. Is no build condition, ADT or AADT, available? This question is vital for comparative analysis. It asks whether you have traffic volume data available for a scenario where no new construction or changes are made to the existing road. Please note that one-way or directional traffic volume should be used for interstate and freeway analyses. Take the time to input this data carefully because it will directly impact the outcomes of your traffic studies. In the fifth section, Traffic Assignment Selection and Hourly Traffic Inputs, you'll make crucial selections related to the type of traffic analysis and input specific traffic data. Analysis type here you need to choose the type of analysis you wish to apply to your project. Demand analysis. This type of analysis allows traffic volume to exceed its capacity to estimate both demand volume and demand speed. Constrained analysis. Unlike demand analysis, constrained analysis does not permit traffic volume to exceed its capacity. Instead, it reallocates any excess volume to off-peak hours. Speed estimates are based on constrained volume. Noise analysis. This method combines aspects of both demand and constrained analyses. It estimates demand volume and constrained speed. Is current hourly speed available? This field asks whether you have data on current hourly speeds. If you do, this data can be used to enhance the accuracy of the analysis. User initial. Enter your initials here. This serves as a record of who conducted the analysis, aiding in project tracking and management. Applying existing hourly volume profile and direction factors. If you have existing data on hourly traffic volumes and direction factors for the interim and design years, select No and input your data in the table provided. If you don't have this data, the tool will automatically apply it based on its algorithms. Apply existing hourly percent truck. This field functions similarly to field 23, but focuses on the percentage of truck traffic. Data table. This table will adjust based on your inputs in fields 22A, 23, and 23B. It operates like an Excel workbook, allowing you to copy and paste data directly if you already have it. A key tip to remember is to always click the Clear Table button before modifying existing input parameters. This is especially important when starting a new analysis after completing a previous one, as it ensures accuracy and prevents data overlap. Each of these inputs is designed to capture specific aspects of your traffic analysis, ensuring a comprehensive evaluation. Accuracy in this section is crucial, as it directly impacts the outcomes of your project's traffic study. Upon completing all the steps, it's crucial to save your ENTRADA input file. This is an important practice for several reasons. Future reference. Saving the file ensures that you have a record of all the inputs and configurations you've made. This is invaluable for future reference, especially if you need to revisit or revise your analysis. Efficiency. By saving the ENTRADA input file, you streamline your future work. The saved ENTRADA input file can be effortlessly imported back into the system using the batch and input function we discussed earlier. Remember, the Save or Export option is typically found within the ENTRADA tool interface. Next, we'll explore the Input Summaries tab. This tab is essential for two key reasons. One is summarization. It provides a consolidated view of all the data you've input, allowing for a quick review and verification. Second is calculation preparation. It also initiates the calculation process, using your inputs to generate the final outputs. Think of the Input Summary tab as your final check before the tool processes your data into meaningful results. Let's move to Output tab. The output of ENTRADA analysis are designed for the use in air and noise studies. In this section, only the process for the calculation of forecasted speeds is explained. The speed outputs are for the following scenarios: existing, interim build, interim no build, design build, and design no build. The build scenarios are self-explanatory and represent the planned improvement conditions. With the exception of the forecasted traffic volumes, the inputs for the no-build scenarios, interim and design, are identical to those for the existing conditions. Move to Speed Post-Processing tab. When users have operating speeds for an existing scenario or a base year, either from the field or from another data source, they can choose to calibrate estimated operating speeds in ENTRADA. If hourly speed data are available, users need to select Yes in Input 22A, Is current hourly speed available? And input the hourly speeds into Input 24 Traffic Data Table. Once ENTRADA completes its computation, indicating that the output is ready, users can navigate to the Speed Post-Processing tab and examine the difference between operating speeds calculated by Entrada based on HCM formula and the hourly speeds provided by users. If the differences are within plus minus 10%, there may be no need to calibrate speeds. If the differences exceed plus minus 10%, it is recommended to run the speed post-processing. If users opt for the speed post-processing, they can simply check the mark in the speed post-processing box on the right panel. Upon clicking Output again, users will observe that existing operation speeds are replaced by their hourly speeds and that future years' operating speeds are simultaneously adjusted. If users require estimated operating speeds based on Entrada's HCM formula again, they can uncheck the mark in the Speed Post-Processing box and click Output. Entrada's output will display the estimated operating speeds for users. Once you've completed your analysis, simply click on Save Output. This action will generate an Excel file containing all the output data. This file is specifically formatted for use with our LHD tool, ensuring seamless integration and further analysis. Here is Loudest Hour Determination Tool, so-called LHD. LHD tool is used in completing highway noise studies. Specifically, the tool is used for determining the worst, loudest case traffic conditions for completing highway noise studies. The tool works hand in hand with Entrada as it takes the hourly traffic data from Entrada and processes the data to determine the loudest hour based on volumes, composition, and speed. Next, let's navigate to the Charts tab. This feature is designed to assist users in visualizing their data, offering a clearer understanding through graphical representations. This tab is an essential tool for comprehensive analysis. Moving on, the Lookup tab provides a wealth of additional resources. Here, you'll find extensive guidance, parameters, and information that are invaluable for effectively utilizing the tool. Whether you're seeking clarification on specific functions or need detailed insights, the Lookup tab is your go-to resource. For users requiring more in-depth assistance, the User Guides tab is available. Within this section, you can download the Entrada User Guide in PDF format. This guide offers detailed instructions and further explanations to enhance your experience with the tool. Additionally, users can access and download Python scripts for A and B directional bound calculations, providing valuable resources for data analysis. Lastly, the Update History tab serves as the Entrada log history. This archive allows users to view all updates to Entrada since its initial release. Keeping track of these updates is vital for understanding the tool's evolution and ensuring you're informed about the latest features and improvements. And that concludes our overview of Entrada. We hope you found this tutorial helpful. Thank you for watching.